Welcome back to our discussion on exceptions from the first sort of to be continued part. We're continuing the discussion here by creating a separate method that's actually going to throw its own exceptions. We're going to talk about how we can add these exceptions, not just catching exceptions in our code, but throwing them as well. So let's just jump right in with that and continue our discussion from the last video. All of this so far has been me showing you how exceptions are being thrown within Java code, within the file reader constructor, within the substring method, within the append method. But the real kicker here is actually that we can throw these exceptions all on our own. For example, let's say that we want to make a new string builder. Make a string builder. And let's just pass in something here. String builder, make a string builder, string code. Whoops. All right. If the code that comes in is going to be an E, we're going to throw a new null pointer exception. You can throw any kind of exception. Exception time. There we go. Else, we can just return. Actually, we don't even need an else. We can just return a new string builder appropriately as expected. Okay, so what we can see here is we can see that our string builder method right here, make a string builder, is going to come into here. It's going to try to run this line. The code I'm passing in right now is indeed E. It's going to throw a new null pointer exception. And like I said, this is basically like an eject button. When an exception is thrown, no matter what the code is doing at the time, it just jumps out of it. It's almost like a return. So when we run this code, oh, did I forget the word static? Sure did. We can see that when we run it, we did get that null pointer exception thanks to the E, and it printed out our message, exception time. If instead I change this to an empty string, my code will run completely as expected and normal. It'll make it, let's just add, making a real string builder, just so that we can have like some kind of indicator that it worked. There we go, making a real string builder. Now, this is incredibly helpful because we can now sort of throw our own exceptions into all sorts of situations. In fact, we can do a couple things here. We can do a try all of this. And a catch right here of the null pointer exception. Make a string builder anyways. So now our code is going to come in. If this is the code, if the code is an E, we're going to throw an exception. I'm going to move this out of here actually. Still in try. And I'll even add a finally. There we go. If the code is an E for exception, we're going to throw that exception. But where is this exception going to be caught? Well, it's going to be caught wherever is closest. And where is closest is actually right here inside the method. So we catch our null pointer exception. It's going to say make a string builder anyways. The finally is going to say making a real SB, and then we can return a new string builder. So this is different from before. Before we threw that null pointer exception and our code exploded. Now we are preventing our code from exploding by catching that null pointer exception right here and still allowing the return to happen normally. Let's go ahead and see this in action. There we go. We can see that oh, this is for this one right here. Whoops. So let's actually, that's fine. I was going to do this second. Whatever. Here we have no exception character. So this comes back as false. Therefore, we go here into still and try. The finally happens no matter what. So it's making a real string builder, and then the real string builder occurs here. Let's go ahead and change this to an E as I meant to do. Clear, compile, run, and we can see now that we did hit this exception right there, exception time. We come into here. We're not actually printing out the words exception time. I'll show you how to do that in a second, but we did come into the catch. We got them make a string builder anyways. Then the finally still ran. It made making a real string builder, and our return occurred. We can even test if the return worked by up here saying if string builder is null, is not null, we have a string builder. If you want to print the error message that you pass in over here, that's where this variable comes into play. We can say npe.getMessage, and that will actually get the message that you entered in the constructor. So let's try this one more time. Now we can see we do hit the exception time. It prints right here. Then it says make a string builder anyways. The finally runs. We return a new string builder right there, making a real string builder. We have a real one because it came back up here and we got our string builder anyway. No problem. Everything worked out just fine. If we want to just quickly look at what would have happened without that, no string builder. If we go back to removing the try catch, we go back to just it doing the throw. Let's see what happens now. Now, if the code is equal to E, we're going to throw an exception, and we're never going to make it to this string because we're not catching it in here. So what's going to happen is we're going to come up here, and let's take a look. There we go. We got our exception throwing. We didn't even get to make it to our code because, oh no, we never actually caught the exception anywhere in our make a string builder or in our main. Well, we want to be able to at least try to run this. So why not put this inside a try catch? Try catch. Now, how do I know what kind of exception this can throw? Well, let me tell you. Any types of exceptions that your code might throw, you should add to the method signature. So string builder, make a string builder, and then right over here, or on a new line also works, you can put the keyword throws with an S and the name of the exception. And now Java knows that this can throw this type of exception. So now I can go here and I can add null pointer exception, and I can say exception came from method, no string builder made. There we go. Let's go ahead and see what the heck is going to happen now. Here we're going to put this back to when it will work. So try to make a new string builder. We're going to come into the string builder. We can see if it equals E what will happen, but it doesn't equal E. So we're going to go ahead and return that new string builder. This try completes running. We jump over the catch, we go here. If the string builder does not equal null, it doesn't equal null. We did make it to the return. We have a string builder. So what should print is we have a string builder. Let's go ahead and give it a run and make sure that is what happens. There we go. Now to show the exception pathway, we add that E in right here. When we go into make a string builder, what's going to happen this time is if the code equals E, we're going to throw a null pointer exception. And what happens is we never get to hit that return. There's no finally, there's nothing. So the throw passes that exception up the call stack. It's going to go back up to main here. Now, instead of our program completely exploding, we do catch it right here. And we will print out that the exception came from the method and no string builder was made. That means that this variable SB will stay as null. So we're going to get this message printing out. Then if SB does not equal null, well, this time it does. So we're going to go into the else. We should end up with 2 lines printing this time. We should get the exception came from method, and we should get the no SB. Let's go ahead and give that a run. Java, and there we go. We get those 2 lines just as we expected. So we can see how we can directly throw an exception when something unexpected happens, even if it doesn't come from one of the built-in Java methods. We don't even have to define our own class or anything. We can just use the built-in values and built-in classes. If you want to learn about all the different types of exceptions that exist, you can always go over to the Java Oracle documentation and you can see them all. Ones that we've already discussed are in here. If we go to runtime, got to find it somewhere in here. Runtime exception right there, and click that. It's going to take us into a deeper circle from our initial Venn diagram. And here we can see things like arithmetic exception. We can also see things like where my index out of bounds exceptions are in here somewhere. My null pointer exception, a negative array size exception. It's often fun to sort of figure out if you can make an exception get thrown as well. So like read these and see if you can figure out how to make your code throw one of these exceptions. So we saw that a throw literally stops the current method and it signals an error. And if nobody catches it, it passed it all the way up to the top and our program terminated with that stack trace. We can use throw when we want to sort of allow a user to correct behavior or if maybe bad data might occur. So we've talked about try, catch, and finally, and a little bit around the best practices, but I think it's really important that we sort of outline the best practices with exception handling right here and now. We only want to catch what we can meaningfully handle. If we can't meaningfully handle it, don't just catch it so your program doesn't explode. Catching a null pointer exception is almost always a bad idea. Catch the most specific error or exception that you can. We saw that we can catch a capital E exception, but that's going to include actual errors in our code that we need to be able to handle properly. Let's give clear, actionable messages in our exception string. So if you're writing an exception string, don't just write exception time like I did. Try your best to give an exception message that will actually tell the user what they did wrong and what they can do better. We prefer try with resources over try. Now, try with resources works exactly the same as try in the sense that we can still have one catch, multiple catches, a finally, but it ensures that we'll close our resources off without having to do it ourselves. And lastly, log your errors for debugging. This means using the exception variable .print stack trace. It's a method. Trace, or some kind of other meaningful logging library or message. We've now seen how exceptions let our program respond gracefully instead of crashing, and how Java distinguishes between checked and unchecked problems, how to use try, catch, and finally properly, how to delegate where the different error messages should get thrown to by adding throws to our method header, and how we can throw methods ourselves as well when something just doesn't feel quite right. This is the end of our strings and file IO and exceptions module. And starting in our next topic, we will be discussing array lists. See you there. Thanks.